It's one of my favorite topics to cover in a pre-calculus, college algebra, or algebra 2 course. The whole idea is zeros of polynomial functions. So we're going to go slow through this. This is going to be part 1 of a 3-part video series. So the first thing we're going to need on this is the remainder theorem. Now, the definition of this, or the theorem, is kind of hard to read itself. A polynomial f of x is divided by x minus k. So we're still dividing polynomials here, where we're going to switch the signs on this factor, x minus k. Then the remainder is the function value, f of k. Okay. So to illustrate this, what I'm going to ask you to do is you're going to use the remainder theorem to evaluate this function, this polynomial function at x equals -2. We've worked problems like this in the last month. That's just where we plug in -2 in for all these x's, and then we see what the answer is. The remainder theorem says that we can use synthetic division to help us get that answer. I'll write out my coefficients here, as we did yesterday. This is a little different. This isn't x minus 2. This is x equals negative. This -2 actually just gets plugged right in. We actually solved it for x in this case. So from here, I just do my synthetic division from yesterday. I'm going to multiply and then add. Keep the numbers pretty small. So here I get a -56. And so what the remainder theorem is saying is that if I plug in -2 for all these x's, so I'm just going to kind of do this in my head, -2 for all these x's, 16 minus 16, right? And then that's, 4. Maybe I don't need to do this in my head. -44. And then a positive 16. If I was to fill all these out, let's see, those give me 48. 48 minus 44, 4. Now, if I add all these together, it gives me the same -56 that is in this remainder down here. And that is my remainder theorem. So I will want you to be evaluating this relate in your head that we have done this already. We just found a better way, a neater way of doing it. So the other theorem I want to talk about today is the factor theorem. So according to the factor theorem, k is a 0. K is a 0. K is a solution. K is a x minus k is a factor. Okay, and that's going to be true. F and only f, like I said, x minus k is a factor. So I'm going to couple that with the remainder theorem to show you what's going to happen on these problems over the next few days. So they're going to give me a factor. So what's going to happen is this f of x right here, it's going to break down. I'm wanting to break it down into factors. And I know that one of them is going to be x minus 1. If I would have some neat way of factoring that all the way down. What I want to do is I want to find the remaining factors and then use them to find the zeros of the polynomial. So here we go. That's kind of what we did yesterday. So I'm just going to take this f of x, my polynomial, and divide it by x minus 1. So that means I need to use a plus 1. Now, since it says this is a factor, that means that my remainder will equal 0. So if I work this correctly, I should get a 0 down there. Okay, so I'm going to drop right here, multiply and add, multiply, add, multiply, and sure enough, I get 0. So, before I can factor this all the way down, what I'm going to do is I'm going to rewrite my f of x. Still have the x minus 1. And what I can do is I can take this equation. This is called a depressed equation right here. 2x squared minus x minus 6. And I want to continue to factor this. Well, we spent the first month of this school year talking about how to factor quadratics. So I split up the 2x squared as 2x and x, and I have the good old DHS guess and check from here. I do believe that if I put a -3 right here and a +2, that works for me. So what I have done is I have found the remaining factors. Okay. This is what the factorization looks like. I want to use them to determine the zeros. So the zeros is going to be what makes the remainder 0. What makes the whole thing equal to 0. And so if I just take each one of these factors, set them equal to 0 and solve. On this one, I'm adding 3, dividing by 2. To get my remaining zeros. What does that mean? That means if I was to plug in 1 into my f of x right here, of course it gave me 0. We just saw that right here with this synthetic division. But I also could have plugged in 3/2 in for x, or into my synthetic division, or I could have plugged in a -2 over here, and it still would have given me a 0 right there. Okay. And next week, this is going to help me graph. These are going to be, we know that they're factors, they're solutions, they're zeros, and these are also x-intercepts. These tell me where they cross the x-axis. Now, one thing I want to make sure that you are doing is working with the depressed polynomial. And that sounds really sad, doesn't it? So whenever I'm actually dividing these and I work this out, I want to take this number down here, these coefficients, and actually plug it into, this is what I want to work with. That's what I want to factor with. Okay, so make sure you're doing that. Once you find that this is equal to 0 right here, this original problem isn't a lot of use to us anymore. Okay. So step by step, kind of what I did on that last problem is right here. If you need to, you can pause this, write it down. If not, I'm going to have you guys try one more. So I'm not really interested in the factor of it. My end goal is going to be just to simply find the zeros. Okay. So go ahead and pause the video, give it a go, and see if you can find the zeros. Did you remember your placeholder right here? Hope you did. If not, go back and put it in and try again on the problem. Trying to trick you a little bit on this one. If you tried to factor this, you might have ran into some problems. How in the world does that factor? Right? Answer is it does not factor. Unfortunately, on this one, you don't get a rational 0. Okay, this 3 right here is going to be a rational 0. So I am going to get x equals 3 down here. But what about my other zeros that I should have? Well, I just have to turn to something else. As said on the last slide, turn to another method if it doesn't factor. Completing the square would be an absolute mess on this. So I'm just going to stick with my friend, the quadratic equation, quadratic formula. X equals -b plus or minus square root of b squared minus 4 times a times c all over 2a. This isn't going to clean up just a whole bunch. That's 1 plus 60 over -10. So that would give me -1 plus or minus the square root of 61 over -10. And that, unfortunately, is my last two zeros. They are not promised to be nice on this. About half of them will be nice in the homework. The other half, they could get pretty gross. So I get -1 plus the square root of 61 over 10. And -1 minus the square root of 61 over, oops, that should be negative things. Okay. That is it for part 1. Tomorrow, I'm going to try to take off this safety net of telling you what a zero is and see if we can start from scratch with a polynomial function.